By connecting to your code repository, Accurix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix. Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. As the world of software-driven everything becomes a reality and development cycles speed up, sales teams are taking a new approach to application security, one that enables security teams to scale by empowering developers to integrate security into their development workflows and toolsets, all while giving security teams the visibility and control they need. Snyk helps software-driven businesses develop fast and stay secure with a developer-first solution that seamlessly and proactively finds and fixes vulnerabilities in open-source libraries and containers. Learn more and see the solution for yourself at securityweekly.com/Snyk.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman. We are looking for high-quality guest suggestions for all of our podcasts to fill our Q3 recording schedule. Submit your suggestions for guests by visiting securityweekly.com/guests and submitting the form. We review suggestions monthly and will reach out to you once reviewed. In our first July webcast, you will learn how to stitch and enrich flow data for security with Viavi solutions. Register for our upcoming webcasts or virtual trainings by visiting securityweekly.com/webcasts or visit securityweekly.com/on-demand to view our previously recorded webcasts. That brings us to the news. So, Matt, in our last segment, we actually heard some great journey going from the lift and shift data centers into the cloud to a more of a drift and fix type of very proactive, very positive solution. Unfortunately, in the news today, there's still a lot of software that needs to be fixed. The one in particular, and this one that is actually something that John flagged. So, John, we're making sure we did our homework and we read through some of your articles. It's about DLL hijacking. So this one in particular was a report that was updated about Trend Micro Password Manager. And so the researcher, I think actually looking at the timeline of this, identified this way back in August 2019 when it was initially evaluated as medium risk by the vendor, then updated to be high risk, which is notable and good just for a good positive communication between researchers and a company in terms of identifying vulnerabilities. But I did just want to highlight more just the aspect of what DLL hell if you're a developer, trying to build software on top of Microsoft Windows, as well as DLLs as the attack vector for basically Trojaning existing processes running on Windows and Microsoft systems.
Yeah, we see this with this is a concept that also comes out of the container space a little bit as well, right? We have these interesting binaries that sometimes we don't have visibility into. In this case, they're Windows DLLs, which I think everybody kind of knows how these things work. But what I thought was interesting about this attack is how they bypassed some basic checks in order to get a malicious DLL loaded, right? And it was a combination of I think, a Firefox kind of capability, as well as the way Trend wrote this code that allowed this DLL, this malicious DLL, to get loaded and bypass UAC and some of the other controls that Windows put in place to protect against some of this.
Yeah, and there's a second article linked here too that gives a bit more of a summary of just the background of the different ways to get a DLL, a malicious DLL loaded by an application. And the researcher actually went through and enumerated a bunch of different software components that look to be vulnerable to this type of loading. And to your point too, it just adds that additional complexity that when you're on a runtime environment and you're pulling in resources from others, if those resources have weaknesses in terms of just the path that they're looking at for loading DLLs, or they're not signed binaries, or they're not checking signatures of what they're loading, then you may be doing the right thing, but what you're depending on isn't. So just another good way of pointing out supply chain problems.
Yeah, exactly. And this is a great example on Windows, but this same kind of problem exists with a lot of open source code that's being used to build these new applications. You get some of the same kinds of attacks possible because you've got these binaries that you don't really know are there. They're loaded. They could be used maliciously to do something you didn't expect your application to do because you didn't even know the binary necessarily was even there.
Absolutely, and just we're not picking on Microsoft today. We're just focusing on it. But Linux systems have LD preload, environment variable, and that's pretty much is going to introduce pretty much the exact same thing in terms of here's a binary that it's loading some shared object that it wasn't expecting, or one that's malicious because the environment and its load order has been tampered with. So fun stuff. Speaking of fun stuff, we have finally a announcement from Adobe that is worth paying attention to, which is basically EOL for Flash. And I didn't highlight this so much because beating up on Flash is one of the easiest things to do in the world. But point out more that it's putting an end of life on any software actually is pretty hard. Just we can pull another couple examples for things like trying to just get off TLS 1.0 and 1.1, getting to 1.2 only, as well as other types of software. And in this case, Flash probably should have been gone at least 10 years ago when HTML5 introduced a lot of the audio video capabilities native to the browser. So I wanted to highlight this article more as a way to highlight, yes, here's a company struggling to end of life one of its services, but kind of a thought exercise for companies internally. What do you have that are internally built services even that you're trying to end of life or deprecate yourself so you can get rid of tech debt? And I think that's kind of a sort of buried lead here of this type of article.
Yeah, I had a few thoughts on this. One, we only have 6 months more of picking on Flash Player. I mean, is that it? I think it'll actually go on longer than that, by the way. Look, there's right. So much legacy stuff out there. I don't know how, even though it's end of life and they're going to prompt to get rid of this, my guess is there's enough legacy stuff out there. It's not going to happen by the end of the year, which means some of this hangs around for a while longer. To your end of life discussion, I mean, come on, we're still going through the Python 2.7 to 3 migration, right? And Python 2's been dead since the beginning of the year, or something like that, Mike. So any of these end of life projects where you have a lot of legacy stuff tied to them makes it very difficult to move quickly. And so we see it internally with some of the stuff we're doing, but think about how many things are dependent on this Flash player that have been there forever. I mean, these Flash player plugins are still required to run like certain content and movies on certain websites, even to this day. So to say that in 6 months this is all gone, I just don't believe it.
2020 has been a rough year. I was trying to find at least one bit of good news, Matt. So give me something here. but I agree. I think honestly, like Flash is probably like the advertising industry is probably the one thing that has kept Flash alive because of banner ads relying on that type of player. I will also note, possibly more importantly for credit cards and for payments, is that Adobe is also trying to end of life Magenta 1.x. And we've talked about it in the past because it's also unfortunately a bit notorious for having software vulnerabilities, and it's an online e-commerce, open source e-commerce basically. So another thing to keep your eye on as you're still trying to get off of Python 2.7 and so on. That does give us a good segue, I think, into talk about from Sneak the open source security report. So there was a lot of cool data in here, and a couple things stood out to me. Is that one? I'm just going to sigh at the fact that cross-site scripting and SQL injection still get mentioned and show up there, but I think that's just kind of a foregone conclusion. It's a failure of the security community's awareness that we need to be less aware of cross-site scripting and actually do something about it, like build something more frameworks like React. But that's my soapbox on cross-site scripting. More interesting though is the dependencies and just how much this is pointing out that dependencies are where the flaws are, but I think they're also where the breaches come from too. And so, just tracking the dependencies and keeping a good story around them having dependencies up to date gets you really far ahead in your security, the security of your applications.
Yeah, we did a webcast with Sneak. They're obviously a sponsor of this show, and we did a webcast with them we actually were hacking an application that had passed some basic vulnerability scans. Because to your point, the dependency hell that open source projects go through, I think is really difficult for people to fully understand. There's a number of open source tools out there that will scan kind of that first line of dependencies, based on what's in your package. But then when you kind of roll down 2, 3, 4 layers deep, there's a lot of stuff some of these commercial scanners don't get. And this is where Sneak has some really interesting capabilities to build out these dependency graphs to look for these vulnerabilities that are buried way down below the surface where you don't expect them. Back to the DLL conversation, right? A little bit, is there's a lot of binaries that get pulled into packages that you don't realize are there. And that webcast does a really great job of kind of highlighting where some of those are. Take all that capability, now you get this really interesting set of open source reports, because they're not just looking at the base libraries, they're also looking at all the dependencies of these libraries to really get a good understanding of what is getting pulled into packages, what's really the risks in these open source packages. I think that's the visibility more of us need to see in order to understand the true impact of binaries and dependencies and all the fun with open source.
Absolutely. And I think they have a bunch of graphs about the top vulnerabilities by year. And I think those are really great visualizations that drive home that message you're just describing. Some of it, of course, is a little bit of observation bias because we actually have a better way to view and inspect that dependency graph, so we can just see that there are more vulnerabilities out there. But I think I would make a strong argument, the case that, yes, cross-site scripting should be fixed, and it can be impactful, but I think where the real breaches and the real exploitable vulnerabilities come from, or where bigger risk is coming from, really is those dependencies. And of course, in one of those top vulnerabilities by year, it did highlight that directory traversal was hugely prevalent inside NPM. It was in orders of magnitude higher than the other language packages. So I don't know what's going on with NPM, but I think it's going to pop up in the news every week now, occasionally, I'm going to have to say.
Yes, one of your favorite vulnerabilities back to the table.
That's it. Now, speaking of favorite vulnerabilities, there was, if you're looking at the Kubernetes section, about half of the respondents in this survey had Kubernetes. And of that half, 40% of the respondents said that they were reviewing and enforcing a non-root container context. So I think somebody's been listening to you. Your message is getting across, Matt, if slowly.
Just slowly. I've been saying it for what? Let's see. Say it is 17. Yeah, almost 3 years now. So we're getting there.
All right. Well, we'll check back in 2023, whatever episode number that will be, to see how things look. But I think another thing that stood out to me from that Kubernetes perspective in this report is that, a little bit of a callback when we're talking about with Caesar and saying, infrastructure as code and just being able to review your Terraform configs. You can actually see what is your environment, what does it actually look like, or what's it supposed to look like once it is in fact deployed? That's a really strong, high confidence feedback loop right there. And in this case, only about less than a third actually of respondents said they were doing any automated configuration reviews within Kubernetes, which seemed kind of surprising because in my mind, that seems like a really smart place to go. Just look at your look for misconfigurations. They're there in roughly human readable code and very machine readable code. And you can fix a lot of easy, obvious problems that way.
Yeah, but misconfiguration isn't sexy, Mike. Come on. It's much more fun to do static scan and analysis, dynamic scanning, implement some instrumentation to do some runtime security. Who cares about configuration? I'm being facetious because we know this is where a lot of these breaches happen. I mean, the Verizon report highlighted it. We covered that a few weeks ago. I mean, misconfiguration is one of the top items. And this is one of the reasons why I like what Accurix is doing, is because when you can start to look at the configuration as code before it's deployed, look for potential weaknesses that you can solve in the pipeline before you deploy, you're going to reduce the number of potential attack and breaches that are out there. And then this really interesting concept of then tracking what's in production versus what you think's in production. This whole drift concept is very interesting because we all know we don't do it correctly sometimes, right? We go right into production and make that change. That creates some interesting security and resiliency issues that we talked about. But again, configuration isn't a really sexy topic. And that's why I think you see the numbers so low, Mike.
Yeah, and I think one of the things that I'd really want to repeat that you just said too is that it's not just even, you can get more than just security out of doing configuration analysis or that Terraform analysis, pointing to resiliency, looking to say, how are you distributed across regions? What's your how well can you be, ensure availability and uptime? Those are great fundamental engineering benefits too. And actually, I think we didn't even mention cost. Clouds, misconfigured or deployed systems in a cloud can actually spin up a lot of CPU or data transfer cost, where your configuration analysis can help you. So I'm basically trying to make something sexy about this configuration analysis so that we can, drive that number up from 28, 30% to at least over 50, so we can do better than flipping a coin to find out if somebody's doing this or not.
Exactly. In one quick story on that, we had one of our EC2 instances misconfigured. Its configuration was set up for like fast snapshots from a restore perspective. On that one EC2 instance, it was over $500 that month. And we're like, thank God it was only one instead of all seven, because all the extra costs associated with that simple misconfiguration, it also costs you money too. It can cost you a lot of money.
That absolutely does. So you can scale all kinds of things. You can scale up how much money you want to spend, intentionally or very unintentionally, as you're pointing out. Yes. That also gives us a good chance to go into the next article. So I brought one out that was a discussion between microservices versus monoliths. And I thought there were some pretty interesting pros and cons and just some ways to have this discussion. I will kind of sort of short circuit part of the conversation and say, as with everything security, it depends on context. But I think really there's the underlying message here is more about how mature is your DevOps culture and your SDLC pipeline, or your CI/CD pipeline, your security development lifecycle. And depending on how mature it is, a lot of these cons kind of go away. But I'm curious if you had a chance to look at this and there was something that stood out to you, and if you'd fall on the monolith or the microservices side for any particular reason.
Yeah, I mean, it's interesting, right? When I think about our own internal application that is really a monolith today in Python 2.7, but we want to make it microservice based because we see the benefits of doing that. It takes time. There's pros and there's cons, right? Mm-hmm. So you've got this code base that has been slowly maturing over the past couple years, making a lot of great improvements. But then we can see, well, if we could take publishing, for example, and split it off into its own microservice, maybe as a Lambda function, and it spins up and it does its thing, and publishes all the content and then spins itself down. There's great benefit to that. But to create that architecture takes time, right? And so how do you balance that migration from a monolith to a microservice base? Luckily, Paul and Marcin get to deal with that on a daily basis. But look, this is what I think a lot of organizations are struggling with, is how do you make this, first of all, benefit discussion, right? Does it make sense for me to break this big thing up into smaller parts? And then if it does, how do I get there effectively, securing it along the way? These are a lot of challenges I think organizations fight with. And, I think this article does a good job of pointing out some of the pros and cons, but it does boil down to a level of maturity. Microservice-based architectures are highly complex. They create a lot of a potential attack surface. And if you're not looking at things like we've been talking about today, configuration of the infrastructure, configuration of the cloud services that you're using, et cetera, how are you going to secure a highly distributed application?
Yeah, I think some things I'd add to that is absolutely the testing for microservices can be really complex because it can be harder to set up the state necessary to interact and find some logic bugs or those more types of flaws within a particular workflow. So that's definitely a tougher one. The attack surface is equally tough, especially if you're not doing a homogeneous language environment, homogeneous frameworks. If you're just saying you can use, this could be Golang, this could be Ruby, Java, Python, etc., that definitely increases your attack surface. One of the things that I would still point out, and the problems that I've seen, or a problem I've seen with Monolith, is that it can also have the dependency updating and curation process can actually get pretty hard because you tend to have then a diffusion of responsibility, and no one is, there may be 5 or 6 different teams relying on one particular dependency, but none of them, all of them are pointing to the others to say, oh, I thought you were responsible for updating that or fixing that vulnerability. So there does need to be some more explicit kind of assignment and expectations about who's doing that. And it can potentially be a little bit slow just because one change in a monolith can have a lot of cascading breaks. So hopefully you have a lot of good testing. I think a lot of this, when we talk about maturity, that's not quite synonymous with testing, but testing absolutely is a key component to it.
Thus our challenge from Python 2.7 to 3.x.
Yeah, developers, I don't think many of them love either writing documentation or tests, although many of them, and the majority, I hope, recognize the value in both. So it's a tough one. Sorry, Paul. So there was another article, so shifting more to an engineering aspect, and we started this year off actually talking about privacy engineering and privacy by design, and I think it was just our last episode we were talking about privacy by design. And so here is Apple. They had a bunch of announcements from WWDC about iOS 14, as well as some upcoming changes in Safari and Mac OS. And I wanted to highlight one track of them, which is essentially how they're describing their approach to privacy engineering. And to me, this stood out because it was, rather than giving lip service to privacy or saying, here's how we take your security or privacy very important, which is what's the common cliche in breach notifications these days, they're showing an engineering approach to it. And I thought this was pretty cool because they had some concrete examples in managing photos, managing contacts, geolocation, DNS, for example. And a lot of their discussion went through and said, these are the features, these are the use cases that people are looking for. And these are how we're addressing those use cases. So they're not saying thou shalt not do this anymore and access any of this data. They're just showing you can actually still, for the most part, access the same data you need. You're just doing it in much more refined and restricted manner that shouldn't impact the actual functionality of a lot of the features and capabilities that applications are relying on. So I thought it was pretty interesting from those perspectives.
Yeah, I think Apple's made some very interesting progress when it comes to privacy. I mean, anybody who's gone through the upgrades to 15 and 15.3 or whatever, 5, whatever it is now, I mean, you see that you have to enable a bunch of things, and a lot of things get turned off by default during these upgrades, right? So they are very cognizant about what applications have access to, what things you can and can't have on from a notifications, et cetera. So, I mean, they're making a lot of progress here. And I think it's completely different than some of the things that Facebook and others have been doing. So I think this is a great example in the tech space of people who are taking privacy a little more seriously in really to build out aspects of that trust. I mean, if you think about the Apple ecosystem, the reason people are all in on Apple is they like the interconnectivity, but there's also a level of trust there. And once you buy in, they want to keep that trust. They don't want you going to Android or Samsung or some of these other places, right? They want to keep you there. So I think they're making the right moves. The other announcement that came out, obviously, which is the next article, is moving to the ARM processor, moving away from the Intel-based chips. This is the old PowerPC to Intel, now to ARM discussion, which I thought was a really interesting announcement. Because now what you're going to get is a lot more compatibility of applications across the mobile platform to the traditional MacBook and Mac product lines now, which I think is really compelling when you think about being able to transport application usage and data and things back and forth, having the same processors on the phones and the Mac product line, I think is really interesting.
Yeah, it is interesting to see because they have the Mac OS and then the iOS and iPad OS split out. Same with tvOS. But if their underlying chipsets, if they're unifying that, then it may be just easier for that developer ecosystem to share data, share apps among those different environments. Not to mention, I'm also curious on what more security properties they're going to bring out of bespoke chips and having, tying into their trusted enclave, their security enclave, and what that's going to unlock. The other thing I did want to mention too about the move to ARM, we mentioned, I can't remember which episode, but Azaria Labs. She's a security researcher that has a fantastic amount of training and content around reverse engineering and analysis of ARM. So this is going to be great. It's just another great resource to start to read up on as the iOS ecosystem is moving to ARM now.
Yeah, I thought what was interesting, we know how security on chip turned out with the whole Intel McAfee thing. Well, let's see if Apple can actually do it better.
Yeah, we'll see if they do better. There's also, if we want to be slightly hardware geeky for a little bit too, there's also RISC-V, which is trying to get out of a purely academic type of instruction set architecture that's driven by Berkeley, I believe, and trying to find its place in IoT devices and other small computing devices, because it can also have a lot of very strong security properties. So I think this move to ARM and the research in areas like RISC-V are going to give us some better encryption, some better security models within the hardware itself. At least that's where I have my fingers crossed. And it also reminded me, what was the other thing? Looping back to, you'd mentioned too about the talking about the privacy aspects of Apple and having a lot of the pop-ups, user notifications. That ties into the DLL hell we were talking about too, because Microsoft introduced their UAC, that user access control, which was essentially a security boundary that tries to pull in the user that says, you're about to run malicious software. Are you sure? You basically click yes or no. Is pretty much the equivalent of, this certificate has expired. Should I trust it or not? I think Apple has the potential to accidentally go down that route of annoying the user with just something bad is happening. Do you want to continue? Or maybe not judging it, just saying something is happening. Do you want to continue? And too many of those prompts just users become inured to them and kind of ignore them. So that will also be interesting to see how that evolves from their designs, from their UX designs.
Oh, yeah, there's definitely some fun challenges with that, Mike. I mean, every time you upgrade, it's like, do I want to see these Sophos notifications, allow or disallow? You have to give access to Sophos, for example, to gain full disk access so it can scan for viruses. I mean, yes, it can get annoying at times, but you definitely see that you're also kind of revalidating some of those things you may not have thought about when you installed some of that software the first time. Like, what do they really have access to? Are they sharing data back to the vendor and you don't really want them to share that data? So it's a good check sometimes to make sure that the applications you previously installed don't have a lot of extra permissions you don't want them to have.
That's a great point, because even already with, I think it was the iOS preview, was already highlighting a bunch of capabilities that TikTok had been asking for example, like cut and paste. And while there may be legitimate reasons why there's some analysis there, whether it's ease of use, whether it's application performance, just knowing that that's going on and highlighting that for the user is pretty important. So, what you were just saying is already caught out at least one app, and it remains to be seen how many more apps are going to have to change their behavior proactively, or a lot of users are going to be suddenly surprised about, approving the capabilities that all these apps have been previously had silently been grasping for.
Mm-hmm. Exactly.
We did have one final. Unfortunately, John's not here to defend himself, but I pulled in an article from John Kinsella himself about what modern CI/CD should look like. So we might dive into this perhaps in more detail next week. But I did want to highlight it just as a nice visual reference too, because he walks through CI/CD and security touch points, if you will, for Amazon, GCP, and Azure. And I just thought it was a nice way to have a visual presentation of that to really drive home what are you doing where, in that sense of how mature is your process, going back to that idea of that discussion about the monolith and microservices.
Yeah, so I need to give you guys the backstory on where these two blog posts actually came from. So as John was preparing his presentation for the Container Security Summit as part of InfoSec World last week, he was doing all this research, and he pinged me offline, and he said, I got a question for you. He said, I'm going through all the cloud environment stuff, and there's nothing about security anywhere in their conversations. And he goes, that just seems a little odd to me. And I said, not really, John. I mean, think about it, right? They're there to try to get you to use their software to help you build applications. They don't want security getting in the way. Come on. I mean, think about this, right? When we were back at Layered Insight, we used to have these conversations with the cloud providers. And so it prompted him to create the first blog post around the cloud side, and then this one, which was kind of the follow-up to it, to say, where does security actually get integrated in these different CI/CD pipelines across these cloud providers? So that's kind of the backstory. We should have him we should get more into the article next week when he's back, when he's feeling better, to really dig into some of this, because I've done variations of this presentation that he kind of highlighted in this particular article. But what he's trying to do is really pinpoint where are the different security checkpoints along the CI/CD pipelines. And this is very focused on kind of AWS, Azure, and Google Cloud, to make sure that people who are leveraging these services think about these different security checkpoints along the way. I thought he did a really good job actually building this article out.
Yeah, and it's a good complement too with our discussion with Caesar, because we have the idea, here's your infrastructure, and you can analyze the code, inspect the code, and figure out what the deployed environment looks like, or how we want it to look like. And then here is the way, as you very helpfully expanded on, to describe what's the software running in that environment now, how can that be secured. So let's definitely put a bookmark there. And John, hopefully as you listen to this later in the week, you're on the hook, do your homework, and come prepared, and we'll talk about this some more. With that, I want to say thank you, Matt, for another great conversation about the AppSec news of the week. I want to thank everyone in the Discord channel for hanging out with us, and all of you who have been listening. Thanks for joining us. We'll see you again next week on Application Security Weekly.